Welcome to the deep dive. We take complex systems, pull them apart, and basically hand you the user manual.
And today, we're tackling a really intricate one.
Yeah, today it's the big one. The biological script behind reproductive hormones, the menstrual cycle, and crucially, how things shift to support early pregnancy.
It's such a fantastic example of biological feedback loops,
Yeah.
checks and balances where timing is absolutely everything.
Right.
It's not just like four hormones doing their own
Yeah,
thing.
yeah.
It's this constant dynamic conversation between the brain, the pituitary gland, and the ovaries.
That's exactly our mission today. We're not just listing definitions. We want to get into the mechanism. We're viewing the cycle like a two-act play, all coordinated by that hypothalamic pituitary ovarian axis. So Act 1.
The follicular phase, that's all about preparation, building things up.
And Act 2.
The luteal phase, stability and waiting. Kind of a wait-and-see situation.
Okay, so we have the core hormones for the cycle itself, 4 of them.
That's right. FSH, LH, estrogen, and progesterone. They're the main quartet driving the regular cycle.
And then if pregnancy happens, the script changes, right? New players come on stage.
Sort of. 3 key players take the spotlight. HCG is the big new one. And then estrogen and progesterone get, let's say, expanded roles. They have to pivot fast.
So by the end of this, you, the listener, should really understand not just what each hormone does, but how the body pulls these very precise regulatory levers. You know, how timing works down to the hour.
Yeah, like how rising estrogen first tells the brain to slow down.
Puts the brakes on.
Exactly. Until suddenly it slams the accelerator and triggers that massive surge. It's quite dramatic.
Okay, let's unpack this. Where do we start? Brain first.
Always start with the conductors. The anterior pituitary gland, specifically. It's command central for our first 2 hormones, FSH and LH.
Got it. So FSH first, follicle-stimulating hormone. Sounds descriptive, but what's it actually stimulating and when?
So FSH is basically the starting gun for the cycle. The pituitary releases it right at the beginning, like day 1 of the period.
Okay.
Its job is to wake up a group, a cohort of tiny ovarian follicles and tell them, okay, time to start growing. It's essentially kicking off a race.
A race to produce an egg.
Well, yes, but here's where the feedback mechanism starts. As those follicles grow, guess what they start making?
Ah, estrogen, the builder hormone.
Exactly. The architect, as you called it. So rising estrogen, coming from these follicles that FSH woke up, has 2 really critical jobs in this first phase, the follicular phase.
Okay, job 1.
Job 1 is building. It tells the uterine lining, the endometrium, to grow rapidly, thicken up, get plush. Preparing the nursery, you could say.
Makes sense. Preparing for a potential arrival, job 2.
Job 2 is communication, feedback. This rising estrogen talks back to the brain, specifically the pituitary.
Wait, hang on. So the ovary, responding to FSH, sends estrogen back up to the pituitary that sent the FSH in the first place.
Oh, precisely.
What's it telling it? Thanks, we got this.
Sort of. Initially, in that first week or so, as estrogen levels climb steadily but not spectacularly, it puts the brakes on. It exerts negative feedback, meaning it tells the pituitary, okay, you can ease up on releasing more FSH now. This is clever because it helps ensure only the strongest follicle, the one producing the most estrogen, keeps going.
Ah, survival of the fittest follicle.
Basically, yeah. The others that can't keep up, they undergo atresia, they just die off. It focuses resources on selecting usually just one dominant egg. Very efficient.
Okay, that's neat. Streamlining the process. We have a winner, snow down the starting gun. But ovulation needs a trigger.
That negative feedback has to flip somehow, right? How does that happen?
That flip is honestly the most dramatic moment. When estrogen, produced by that one star follicle, hits a really high threshold.
Like super high.
Yes, and crucially, it has to stay that high for about 36 hours, give or take. When that happens, estrogen suddenly flips its message. Instead of negative feedback, that sustained high level triggers positive feedback on the pituitary. Wow, so the same hormone, just at a higher concentration, sends the opposite signal. Instead of slow down, it says go.
You got it. That sustained high estrogen shouts to the pituitary, the egg is mature, it's ready, and the pituitary responds instantly with a massive sudden dump of our 3rd hormone, LH, luteinizing hormone. This is the trigger.
The LH surge, also from the anterior pituitary, right?
Also from the pituitary. This huge spike in LH is the direct cause of ovulation.
So the surge makes the follicle rupture and release the egg.
Yep, but LH isn't done. After the egg departs, LH sticks around and tells the leftover structure, the collapsed follicle, to
transform into what?
Into a temporary but incredibly important little endocrine gland called the corpus luteum.
The yellow body. And that leads us right to hormone number 4.
Progesterone.
the stabilizer.
Okay, so the corpus luteum makes progesterone exclusively in this phase. If estrogen built the house, progesterone makes it livable and secure. It stabilizes that lining estrogen built up, makes it supervascular, nutrient-rich, ready for an embryo to implant. It also thickens cervical mucus.
So progesterone really dominates the second half of the cycle.
Absolutely. Progesterone is the defining feature of the luteal phase.
Okay, let's map this onto the timeline again. Act 1, the follicular phase, driven by estrogen, runs from day 1, start of the period,
to ovulation around day 14, though that can vary a bit.
and this is the prep phase. FSH starts it, follicles grow, estrogen rises, builds the lining.
Steady buildup. Selecting the egg, prepping the uterus.
And the climax of Act 1 is that LH surge, which flips everything.
Instantly. That surge catapults us into Act 2, the luteal phase.
The progesterone-driven phase, the wait and see.
Exactly. Starts right after ovulation, lasts pretty consistently, usually about 12 to 16 days for most women.
And the key player here is that corpus luteum making progesterone. Its health is critical, right? What if it's faulty? Like a weak corpus luteum. I think I've heard of luteal phase defect. Here's where it gets really interesting.
Yes, that's a concept. If the corpus luteum doesn't produce enough progesterone, or if it just gives up too early and breaks down faster than it should,
then what happens to the lining?
then that beautiful lining estrogen built can't be properly maintained. It might start to break down too soon or just not be stable enough.
Meaning the window for implantation gets shorter or maybe isn't even really there.
Potentially, yes. Stability is key in this waiting period. You need that steady progesterone signal.
So progesterone is like the pause button, holding everything stable, waiting for news.
Pretty much. It's waiting for one of two things, either a rescue signal from an implanted embryo or nothing.
And if it gets nothing?
The corpus luteum has a built-in lifespan, naturally about 14 days post-ovulation. If no embryo implants and sends that rescue signal, it just degrades. It dies off.
And when it dies?
Progesterone and estrogen levels plummet. Suddenly, dramatically. Without that hormonal support holding it up, the uterine lining destabilizes and sheds.
Which is menstruation, day 1 all over again, the reset button.
Exactly. Elegant, maybe a bit brutal, but efficient, clears the slate for the next attempt.
Okay, but what if? What if fertilization does happen, an embryo starts developing? That whole reset mechanism has to be stopped, like, immediately.
Immediately is right, because the clock is ticking on that corpus luteum's lifespan.
So the embryo needs to send a signal.
Yes. The moment it implants, which is roughly 6 to 10 days after fertilization, it needs to deploy our next crucial hormone, HCG, human chorionic gonadotropin.
Ah, the pregnancy test hormone.
That's the one. Secreted by the very early embryo, the trophoblast cells that will become the placenta. It's the ultimate rescue signal, the sustainer.
And it has to act fast, right, before the corpus luteum gives up.
Absolutely critical. HCG's number one, most urgent job is to prevent the natural death of the corpus luteum.
How does it do that?
Well, HCG is structurally very similar to LH. It basically mimics LH. It binds to the LH receptors on the corpus luteum.
Ah, so it tricks the corpus luteum, makes it think the LH surge is still happening?
Essentially, yes. It convinces the corpus luteum, hey, keep going, don't shut down. This keeps the corpus luteum alive and, crucially, keeps it churning out high levels of progesterone.
That timing you mentioned earlier, 8 to 10 days post-fertilization for HCG to show up. That's fascinatingly tight.
It really is. The embryo literally has less than 2 weeks from fertilization to implant and start producing enough HCG to override the scheduled self-destruction of the corpus luteum.
Wow.
It's an evolutionary bottleneck, really. The whole system is designed to reset quickly if nothing happens. So the embryo has to immediately signal its presence and take control of its own life support, hormonally speaking.
If that signal is late or too weak,
The corpus luteum dies, progesterone drops, the lining sheds, and the pregnancy ends before it's barely begun, often before someone even knows they're pregnant.
Yeah.
That timing is non-negotiable.
Okay, so HCG rescues the corpus luteum, keeping progesterone high. But progesterone's job doesn't stop there in pregnancy, does it? It does more than just stabilize the lining long term.
Oh, much more. Its role expands massively. Think of it as becoming a biological relaxant and maybe a diplomat.
Okay, relaxant how?
It relaxes smooth muscle tissue throughout the body. Most importantly, this includes the uterus. It helps keep the uterine muscle calm, preventing irritability and contractions that could threaten the pregnancy, especially early on.
Protects the fetus. Makes sense.
Yeah.
And the diplomat role, what's that about?
That relates to the mother's immune system. Remember, the fetus is genetically half foreign material.
Right. Dad's contribution.
Exactly. Progesterone plays a key role in modulating the maternal immune response locally in the uterus, helping to prevent the mother's body from rejecting the fetus as an invader. It helps create immunological tolerance.
Creating a safe zone.
Yeah.
Very important.
Absolutely integral for a hospitable environment.
Meanwhile, what about estrogen? The builder from Act 1, does it come back into play?
Big time.
Mm-hmm.
Later in pregnancy especially, the placenta starts pumping out huge amounts of estrogen. It takes over as the primary growth hormone for all things reproductive.
Oh, it's like
Massive growth of the uterus itself, helping it expand to accommodate the baby. It also ramps up blood flow vasodilation to the uterus, making sure the placenta gets tons of nutrients.
So fuel for growth and delivery systems. Anything else?
Yes, it also gets the mother's body ready for after the birth.
You mean lactation, preparing the breasts?
Exactly. Estrogen stimulates the growth of the milk duct system within the breasts. Progesterone, also still high, helps develop the glandular milk-producing structures. They work together, preparing for feeding the baby. It also contributes to changes needed for labor itself.
Okay, so stepping back, putting the whole HPO axis, the feedback loops, the cycle, the pregnancy hormones all together, what's the big picture?
The big picture is this incredibly elegant, dynamic conversation. The pituitary up in the brain initiates things with FSH and LH.
Kicks it off.
The ovary responds, drives the preparation with estrogen in the follicles, and sends feedback.
Builds the lining, selects the egg.
Then the corpus luteum takes over post-ovulation, dictating the immediate outcome with progesterone.
Stabilize and wait.
And if fertilization happens, the embryo itself performs this amazing hormonal maneuver, bypassing the brain's usual control by using HCG to directly hijack the corpus luteum's progesterone production, forcing stability and preventing the reset.
It really is stunning physiological engineering when you lay it out like that.
Absolutely.
And thinking about that cascade, especially the risk of the whole system just resetting itself, it really hammers home the speed, the urgency required.
That 8 to 10-day deadline for HCG we talked about, it really highlights how critical timing is in biology, perhaps one of the most critical timing events in our bodies.
Yeah, just think about that for a second. Within about a week and a half after fertilization, this tiny group of cells, smaller than a grain of rice, has to physically implant itself, somehow sense that the hormonal support system is about to collapse, synthesize and release enough of a complex hormone, HCG,
Type like a protein, yeah?
to travel through the bloodstream, find specific receptors on that failing corpus luteum, maybe think of it as miles away in cellular terms,
Right.
and chemically convince that gland to stay alive and keep pumping out progesterone, effectively overriding the mother's entire biological default program.
That rapid intervention is literally what makes continued human gestation possible at that very fragile stage.
It's an immediate, high-stakes race against the biological clock, won through incredibly precise hormonal signaling. Amazing stuff.